The following content is provided under WISA Mechanism Group. Hi everyone, today I'll be explaining another static problem that will be helpful for you to understand the load distribution and how to compute the forces in a beam. As we can see in this problem, we have a distributed load of 4 pounds per feet, and we have also two forces that acting on A, one force acting on B, on C. And the question says compute the shear force and bending moment at point B, which is the center of this beam. And now let's see how are we going to solve this problem. Everyone, today I will explain this problem in a different way, and the reason is that I forgot to attach the microphone to my camera. Anyway, the first thing that we want to do is we want to draw the free body diagram of this problem. As we can see, we draw our X and Y forces because we have a pin, and this is why it has two forces, one in the Y direction, the other is in the X direction. And we have one force on C because we don't have a pin, we have a pin with wheels. The distributed load has a force in the center of that load, which is 40 pounds, because we multiply the distance, as we can see, 10 feet by 4 pounds per feet, which gives us 40 pounds in the center of the distributed load. You have to make sure that it is exactly in the center. That means 5 feet in the right half of the distributed load and 5 feet in the left half of the distributed load. And this is how you draw the free body diagram. There's another thing that is gonna be weird in this problem, which is CY and AY/AX is gonna be calculated in the next not in the next video, but in the next moment that we will see. But right now, let's assume that we already calculated, or let's assume that CY is given and AY is given, and of course AX is 0 because we only have one force in the X direction, which means that the sum of the forces in the X direction equal to 0, one force equal to 0. Right now, we cut our beam. As the problem stated, it asks for the moment around B, so we go ahead and cut the beam at B. When we cut the beam at B, we generate a moment which is going out of the page, and a shear force, which is V, going downward. Whenever you cut the beam from the right hand, you always have a moment out of the page and a shear force going downward. The opposite for the same problem when you cut the beam from the other side, which is the left hand. After we cut the beam, the first thing we do is we calculate the sum of the forces in the Y direction, and we come up with AY minus V equals 0. This is going to be our equation. AY is given as we assumed, so V is very easy to calculate. After that, we go ahead and calculate the sum of the moment. The sum of the moment, which called M cut, because we cut the beam, equal to 0, which means that we will have only one force multiplied by the distance, which is 10 feet, which is negative AY, because AY is gonna be into the page. This is why it's negative, multiplied by 10 feet, which is the distance, the vertical distance, plus the moment of the cut, equal to 0. And we found out that the moment of the cut equal to 100. And right now Let's assume that we have to calculate Cy and Ay. So Cy and Ay are not given in this problem. The first thing you want to do is you want to draw the free body diagram, and then after that you have to find, or you have to write two equations. The first one, which is the sum of the forces in the x direction, equal to 0. And we know in this problem that we only have one force in the x direction, which is Ax. That means this force is equal to 0, since it is the only force in this problem. And then we go ahead and say the sum of the forces in the y direction equal to 0. The first one is Ay is going upward, plus Cy is going upward as well, negative 40 pounds, which is the force that comes from the distributed load, negative 40 pounds, equal to 0. We notice that we have two unknowns in the same equation. That means we are going to go ahead and find the sum of the moment around any point you want to choose. In this problem I would choose A, so we say the sum of the moment around A equal to 0. The first force, or the first force I would like to choose to add to my equation, is the force that comes from the distributed load, which is 40 pounds, and this force is gonna be negative because it's gonna go into the page. It's not out of the page, since Y is in the left hand, and this is why it's negative, multiplied by 15 feet, which is the distance from A to the force, the vertical distance. And then we have the other force Cy, which is going out of the page. That means we're gonna add Cy multiplied by 20 feet, which is the vertical distance from point A to C. Why point A? Because we decided that we are going to calculate the moment around A. If we calculate the moment around B, then everything will be different, but we will end up with the same answer. After that we find our Cy, since it's the only unknown in this equation. After that we plug in Cy in the second equation to find Ay. And this is how to solve for the unknowns. And you have to do this before finding the moment around B, or before you cut the beam. You have to find all the unknowns of the problem, and this is in any problem.